Hey, what is up, you guys? Welcome to another episode on the Incredible Academics YouTube channel, guys. Today it's the 25th of January, 2024, right? So we're recording, the video in the early mornings. So we're just gonna focus on finding the area today, okay? So how do we find the area using area rule? Okay, so this is the diagram that we're given, and I hope you guys can see, right? Yes, so this is the diagram that we're given. So the length of BC, that's just 15 units. The length of BD, that's just 12 units, and the angle in between is 50 degrees, right? 50 degrees. So now how do we find the area? We know that the area is going to be 1 over 2, right, multiplied by the product of the adjacent side. The product of the adjacent sides, and the adjacent side whereby there's an included angle. We don't just want any adjacent sides. We want adjacent sides which have got given magnitudes and a given angle in between. For instance, you cannot tell me about BC and DC. Yes, these two are adjacent sides, but the problem is that now we only have one known length, right? Between the two. We want to have both lengths known, right? And if one is unknown, we have to ensure that we find a way, to actually find the length of the other side. So the two lengths need to be known, and the angle in between as well needs to be known. So if we don't know the angle in between, we cannot solve. Even if we had the length of DC, we cannot solve. But BD and BC are very interesting because you can see that their lengths are known, right? So meaning that we can say, okay, BD times BC also times the sine of what? The included angle, which is B, all right? So the angle B is given, meaning that there's nothing that's missing. The angle B is there, the side BC is there, the length of BD is also there. So we're ready to substitute. So before you come up with your formula, make sure that the lengths that you're using are also given before you get stuck. So BD is 12 in length, and BC is 15 times the sine of the included angle. So the included angle, that's just 50 degrees. So let's punch into the calculator and see what we're getting. So 0.5 times 12 times 15 times the sine of 50. Right, and please make sure that your calculator says degrees on top there. Otherwise, if it's saying R, then your answers are going to be you're going to find weird answers. So make sure that you are in degree mode. Okay, so this is units squared. So that's how you find the area, ladies and gentlemen. That's how you find the area. So now let's look at a slightly more interesting question, and even in this case we asked to find the area of the area of this triangle, this polygon. Okay, and the best thing we can do is to sort of like divide the polygon into two sections. Okay, in other words, have the triangle and a rectangle. Divide this into a triangle and a rectangle. Okay, finding the length of a rectangle, how do you go about doing that? So basically that means that we need to find the length of OL. Alright, we need to find the length of OL. Then in that way we can then find the area of the rectangle OLMN. Do you understand? So yes, because with area of a rectangle, it's length times breadth. We do have the breadth, but we don't have the length, but we can find the length. But you see, the area of this triangle over there, we need not worry about it because we already have the length of two adjacent sides and the included angle. So we already sorted with the area of that triangle, but the problem that we're having is the area of the rectangle. So we know if we can find the length of this side, then basically we shall have found our MN, because we know that the opposite sides of a rectangle are equal in length, right? And once that's done, we can sum the area of this rectangle and the area of that triangle, and they give us, you know, they give us the area of the entire, you know, polygon. So let's get right into it. So let's start off by finding LO, one of your subjects, right? So yes, and what can we use? Sine rule, cosine rule. What can we use to find the length? And to me it looks like we need to use cosine. Okay, so LO squared must be equal to the sum of the other sides squared, right? The sum of the squares of the other side, so LK plus OK, right, minus 2 times LK times OK, okay? Then the cosine of the included angle, which is K. So now that we've got this, we just do the substitution. We know we've got 8 plus 8 squared minus 2 times 8 again, and then the cosine of 110 degrees. Okay, so now LO becomes the square root of that whole thing over there, 2 times 8 squared minus 2 times 8 squared again, cosine of 110 degrees, and we're ready to find our LO. Okay, so the square root of 2 times 8 squared plus minus 2 times 8 squared, the cosine of 110 degrees. Remember what I said, make sure that your calculator is in degree mode. There's this sign over there, but I doubt if you guys are going to be able to see it. There's this sign at the top there, okay? My thing is struggling to zoom in, but yeah, there's this sign at the top there. Sometimes it says R, sometimes it says D. Make sure that it's D all the time. Okay, can you see there's math and then there's another sign there? It needs to say D all the time, please. Let's not lose marks unnecessarily. So now the answer is 13.11 units. All right, that's the length of LO. Now if the length of LO is like that, then we're ready to find the area of the area of the rectangle LONM. LONM, which is just length times breadth. Length times breadth, and we know the length is LO, what we've just found. The breadth is 8, and 13.11 times 8, and that is 104.88 units squared. Okay, so we've got the area of the rectangle. Now we need to find the area of the triangle. All right, so we know that we already got what we need. We've got two adjacent sides with known lengths. We also have the included angle between the two adjacent sides, so we're ready to find the area of that triangle. So area of triangle LKO is simply going to be equal to 1/2 times LK times OK, right? And then the sine of that included angle. So yeah, 1/2 times LK, OK, and times the sine of the included angle. So I mean, in mathematics, you're not going to get marks for the formula. So I'm just writing down the formula so that my work makes a lot more sense, because at the end of the day, math is a language of communication. It's not about the marks, but it's about being able to show the person that's going to be marking your work that you actually understand what you're doing. You know what I mean? You gotta make it easier for them to see what's happening, because if anything goes wrong and they're trying to see what happened with your solution, because of the way that you shall have written your answers, you find that they don't know what you did. And if they don't know what you did, then they can't give you as much marks. But anyway, there we go, 30.07 units squared. So now we've got the area. So total area is going to be the sum of the two, 104.88 plus 30.07. Sorry about that, so that you guys could see. So total area, that's the sum of the individual areas, which is the area of the triangle and the area of the rectangle, and that becomes what? Let's sum that up quickly. So 104.88 plus 30.07, 134.95, and that's units squared. All right, you don't always have to say units squared. If you're given the lengths in meters, then you'd say meters squared. If you're given the length in centimeters, then you'd say centimeters squared. It depends on what units you're given, but in this case, unfortunately, there aren't any specific units that we're given. All right, let's do one more problem for the day, and that's gonna be it. All right, we're almost done. Okay, so this looks a little bit more complicated, hey? But what we're going to do is we're going to so we need to find the area. You can see this is 130 degrees, the length of this 130 degrees, and the rest we're not given, y'all. We're not given. Okay. Yes, unfortunately. But what we can do is we can construct this. We can construct this. All right. Because this side is given, and you can see that it's 20 units. Even this side is also given, that is 35 units. And because there's a right angle over there, we can find TV easily. Understand? The length of TV, you can find it easily because that's just the hypotenuse of the triangle TVU. You get what I mean? So TV squared is just the sum of the squares of the individual sides. So that's TU squared plus VU squared, right? Just the side and that side. So then we do the substitution. There's TU is just 20 squared, and then VU it says 35, and then we square it. Then TV becomes the square root of that 20 squared plus 35 squared. So now the square root of 20 squared plus 35 squared, that gives us 5 square root of 65 units. Okay, and that simplifies to 40.31 units. Okay, so we've got TV now, and with TV, what can we do? I mean, this triangle over here, it's not really that much of a big deal to find its area, because we already got the perpendicular height. Do you understand? I mean, in any triangle, when you've got the perpendicular height, you can find the area. We've got the length of the base, we've got the perpendicular height. The only issue that we're having right now is this triangle over here, TWV, and the issue is that we cannot find its area. We cannot find its area simply because we don't have, you know, two adjacent sides. Do you understand? But now that we've got TV, we can actually use it to find VW. Yes, VW, you guys' favorite car. So let's find VW. So according to sine rule, cosine rule, I mean, we don't necessarily have to use cosine rule, do we? Do we have to use cosine rule? I think so, because we're looking for VW, and with VW, I don't think it will be possible for us to find it using sine rule. Okay, you can argue with me, but with sine rule, I don't think so. So, okay, TV squared is equals to VW squared plus TW squared minus 2 times VW times TW, and then the cosine of the included angle, which is just W. So we already got TV, so 40.31, right, must be equal to VW, which is the side that we don't have actually, VW squared plus TW, that's just 25 squared, minus 2 times VW, that we don't have, ladies and gentlemen. times TW, which is 25, and then the cosine of 100 and what? 30 degrees. Remember, 130 degrees, that's just the included angle over there. So now we need to try to manipulate, you guys. We need to solve for VW. Okay. Yes, we need to solve for VW. And by the look of things, we've got something quadratic. You know, I'm actually glad that we bumped into this kind of problem. VW squared, right, minus, so we just simplify that, because you cannot use factorization here. So the minus 2 and the 25 and the cosine of 130 degrees, we're just going to multiply that. So 2 times 25 times the cosine of 130 degrees, and that's a negative number. So with this negative here, it becomes positive 32.14, and then VW. Okay, so and then we take the 40.31 to the other side, so it becomes minus 40.31. So now we're ready to use the quadratic formula because this is quadratic, VW squared, and then VW, I hope you guys know. So we're gonna have two possible values of VW. We're using the quadratic formula now. Grade 11 work, 32.14, right, minus b plus the square root of 32.14 squared minus 4, 1, and then minus 40.31 over 2a. Right, I'm just substituting there. Yeah, that's the quadratic formula. Maybe I should write it down so that you guys can see clearly what's going on. So VW is equal to minus b plus minus the square root of b squared minus 4ac over 2a and the substitution is going to be as follows. Negative, the b is 32.14 minus plus or minus the square root of b squared, 32.14 squared minus 4, 1, and minus 40.31, and this is going to be divided by what? Just 2 times a, which is 1. Okay, and the answers are going to be as follows. We've got 1.21. We also have the other solution. If it's negative, it's not going to count. It's minus 3.35. Okay, so this one, a length cannot be negative, so our answer is actually 1.21. right? So our answer for VW is 1.21. So now that we've got VW, ladies and gentlemen, that's so exciting, because that means we've got two adjacent sides with known lengths and an included angle. So this is 1.21. So the area of that triangle is going to be like this. We're just going to use area rule. So area is going to be equal to 1/2 times the adjacent side, which is 25, and 1.21, then the sine of the included angle, which is 130. All right, 130. So not enough space. 1/2 times 25 times 1.21, and then the sine of 130 degrees. So we just punch that into the calculator and we get the answer 25 times 1.21 times the sine of 130, and that is just 11.59 units squared. So we've got the area of the triangle, which was like the most difficult to find. But hey, I'll tell you what, the area of the other triangle is going to be super easy to find. So we're just going to use half base times perpendicular height, and remember this is our perpendicular height. Okay, with a right angle triangle, guys, you need not use area rule. I mean, even if you do, but it's not necessary, right? So 1/2, 20, and 35. So in fact, we were supposed to substitute the other way around. 1/2, the base is 35, and perpendicular height is just 20, right? And what does that show? It's going to be something, 350 units squared. So we just add that, so that becomes, so total A is going to be the sum of the two, 350 plus 11.59, and that just becomes 361.59 units squared. And ladies and gentlemen, finally we're done. I didn't think we were going to be able to finish, but hey, we did. Guys, so that's how that's how you use area rule to find the area of polygons, the area of triangles, and all that. And sometimes you're gonna have missing sides, and that's why you're gonna have to use a little bit of Pythagoras and a little bit of sine rule, a little bit of cosine rule, to find the missing sides. And I hope you guys learned a lot. And yeah, bye for now. Don't forget to like, subscribe, comment. If you've got any comments, you can drop them in the comment section below, and I'll try to respond as swiftly as possible. But for now, peace out.